This video goes over the topics from Units 1 and 2 from this year. Algebra 2, 7-1. Write the domain and range of a function in interval notation, inequalities, and set notation. Show work by drawing horizontal and vertical lines and labeling the endpoints, as seen in the first problem. Write in both inequality and interval notation. So if we look at the first one, number 1, the example done for you. For domain, that's going to be left, right, x. So you look at the left side of the graph and the right side of the graph. Notice that both on the left and right side there are arrows. This arrow is going left forever. That means negative infinity. This arrow on the right is going right forever. That's positive infinity. So then you just put them together. With inequality notation, you put negative infinity, less than x, less than infinity. For interval notation, put parentheses, negative infinity, comma infinity. Parenthesis. Now, this inequality notation is not really considered proper, so you would just put all real numbers, and that would work too. For the range, it's down, up, y. So you look at the lowest part of the graph and the highest part of the graph. Notice the lowest part of the graph is going down forever. Those are arrows. Going down forever means negative infinity. The top value is the maximum point, or the maximum value of 2. So for inequalities, we would write y is less than or equal to 2. And for interval notation, we put parentheses, negative infinity, comma 2, bracket. Let's pause the video and see if you could do number 3. We are ready to check your answer and go over it. Unpause the video. Alright, let's go over the domain here. Remember, again, domain is left, right, x. And so I'm going to do this in blue. We'll draw a line on the left side and on the right side. Now notice it looks like these lines are just going off the picture. If it does that, we can assume that they're arrows. It will only not be arrows if it has like a specific hole or point, like on number 5, for example. So it's going to the left forever, it's going to the right forever. That's all real numbers. We could just put that as well. X is an element of the real numbers. Interval notation would still be negative infinity to positive infinity. And the range is down, up, y. So we draw a horizontal line going through the lowest part of the graph and the highest part of the graph. So the lowest part of the graph has arrows. The arrows are pointing down forever. That's negative infinity. The highest part of the graph is the maximum value, y equals 3. So we'll have a 3 right here. Y is less than or equal to 3. I'll do one more together. Let's do number 6. So remember, again, domain is left, right, x. We'll draw a line on the left side. Draw a line on the right side, vertical lines. Notice we have arrows on both sides. This was going left forever, that's negative infinity. This right arrow is going right forever, that's positive infinity. So that's all real numbers. And again, the interval notation is negative infinity to positive infinity. Range, down, up, y. We'll draw horizontal lines through the lowest and the highest part of the graph that's graphed. Not the grid, but the function. So, the lowest point is a minimum value of, let's just say these points, these squares are 1 each. It doesn't say, so we could define it ourselves. So it's -2. Our highest is the arrow as point up forever. That means positive infinity. So our interval notation would be from -2 to positive infinity. Y is greater than or equal to -2. Try the rest of these problems on this page on your own. Remember, if we have an open hole, we have dashed lines, it's unbounded, arrows, holes, it could be either of those on the graph or just a line that's cut off. The notation for intervals would be parentheses, inequalities would be less than and greater than signs. If you have points, or it's like you could create a point like it's the top of a max or a min, those would be bounded, solid lines. And for interval notation, be brackets. Equality notation be less than equal to or greater than equal to symbols.